Hi everybody, I am back again with our bash tutorial in which we are covering the Linux hardening, and this is the second part of our tutorial Linux hardening. In this tutorial we will be covering the securing file system in Linux. In our first tutorial we have started to learn how our hardening works, what are the advantages of hardening, and then we have started covering the topics of hardening. So in continuation of those topics, the in this tutorial we will be covering file system in Linux. We all know file system is the addition area which can be hardened. Containment and mounting are the two restrictive measures to reduce the impact of any mishappen in the file system. If we can preserve containment, and if we can automate remounting, it may be soft or hard, then we can preserve the file system from being corrupt. Luke's partitions are used as encryption method for volumes which prevent other users to access the data if mounted on the network. As we know, we don't want our partition to be accessed by other users, so we encrypt it by using loops, and we can also use a crypt tab to auto mount it, and while using that password during startup. Partition can be mounted with file system option so that we can limit the stuff files can do in the file system. This is making the file mutable, making the file making the file we can say set FACL over it, and we can also have special permissions like SUID and GUID. Then we can set sticky bit over it. These type of permissions can make a certain type of malignant behavior more difficult. So if you want that your file shouldn't be shouldn't be corrupt by chance or shouldn't be changed by chance, so you should need to harden it through special permissions. The next thing which we will be covering is our vast variation of file permissions on files is applicable in Linux, but we need to align the needs keeping in mind the business and user requirement. You can't say that I apply a sticky bit on NFS, then what happens? Then it might be the requirement that other users should execute something on it, but now they will not be able to delete any file. But in some NFS environments they want that one shouldn't be deleting other files. But in a version control, you need to make specific permissions on files which are .svn. So this all file permission variation depends on the business requirement. Hardening in the files can be obtained in three ways: by using ACL, file attributes, and special permissions. In Linux, one can secure file from deletion and overwritten by using the file attributes that I already explained. Like if you make file immutable, then nobody can delete it unless it is having a chattr sudo permission. Nobody can delete that file because you have made that file immutable. Now special permissions provides security implications when they are set on binary executable, right? Out of box permissions on individual files can be provided using access control list. Like you want FACL over it, you want what I can say, SUID and GUID. Linux admins are recommended to go for these file level hardenings in order to have more control in user administration in Linux. Absolutely. You want to control your Linux systems in a way that you should know what type of changes are being made. You can't give full permission of war and anybody can come and delete that war. You can't have shadow file. You can't allow anybody to change your shadow file because it is containing encrypted passwords. You can't have bash umask set to 777. So these things you really need to learn and really need to execute on your production environment. So what are the recommendation of file and permission security hardening? Need to use file attributes such as A, D, I, S, J. A is append only, D is don't backup with command, I is immutable, S is synchronous update, and J is journaling respectively. Sticky bit, SUID and GUID should be used in a planned and effective manner. One can use umask permission to provide more secure default permission to the line user in Linux. Yes, you can define that permission in login.x. You can define that permission into bash of your root. so that by default permissions should be controlled. So this is our Linux hardening part 2. Keep watching hardening videos. They are more interesting and more interesting topics like PAM and other are coming. Thanks for watching this. Last but not the least, please subscribe these tutorials. Please subscribe these tutorials. Bye.